Here's the passive infrared sensor I've got breadboarded over there, and it's turning on a relay who is turning on a solid state relay. If I move, that light bulb will turn on. If I stop moving, it will turn off. Right here's the PIR sensor, and its output is driving into a ULN 2003 driver IC, and that driver IC, the driver array IC, is turning on this relay. The relay contacts apply 5 volts DC to the input of the solid state relay. Now I'm not going to move, and it will turn off. And if I move, it turns on. That's amazing, isn't it? I'll put my drawing of the circuit up at the end of the video, and you can experiment with the passive infrared sensor. Now, I got this one from Radio Shack. We got a Radio Shack up the road that I like to go to, and I'll put the part number of that sensor up in the video. I like making circuits like that. Not moving, moving. Not moving, moving. Isn't that fascinating? I've replaced the solid state relay with an LED circuit. I have a 220 ohm current limiting resistor connected to the contacts of the relay, and the other side of the resistor connected to the anode of the green LED and the cathode of the green LED going back to ground. Let's fire up the circuit, and I'll try not to move. Okay, I'll try not to move. There, the relay's off, indicated by the green LED being off. The relay turns off. I just moved, and the relay turned on. Moving. Not moving. Moving. Isn't that fascinating? All right. Okay. When I get to the house, we'll take a look at my drawing of this circuit. We'll see you then. Afternoon all. Here's my drawings of the circuit of the passive infrared sensor that was used to turn on that 120 volt AC 100 watt light bulb. Now this was absolute fun. I enjoyed this experiment right here. Not only building the circuit on the breadboard, but seeing how this passive infrared sensor works. Now there's 3 pins. VCC, which is tied up to an external plus 5 volt DC, and ground to the same external power supply, and an output pin. Now when the PIR senses movement, the output goes high. And when there's no movement, the output is at ground potential, 0 volts. So you have logic high and a logic low. When movement is sensed, and we have a high out here, it is applied to the input of the ULN 2003. When we have a high on the input of 5 volts, the output is connected to ground down here, the E pin on the ULN 2003. And when we have this connected to ground, we have current flow from the plus 5 volt DC, this same one here, external 5 volt DC, flows through the coil of this relay, this 5 volt coil relay, to ground. So we have a magnetic field built up in this relay. The relay part number is G6B-2114P, manufactured by Omron. Now when we have that magnetic field built up, its contact is closed. And now 5 volts is applied to plus 3 pin on this solid state relay, part number HD4850-10, manufactured by Cridum. And inside here is an optocoupler input to a triac output, separated by that optocoupler circuitry. So we have 5 volts applied to pin 3, that's your plus input, and 4 to ground of that 5 volt DC power supply. And when that 5 volts is applied, we have the output, the triac output, is turned on. And AC current flows from our 120 volts AC single phase. It flows through the light bulb, 120 volt, 100 watt light bulb, through the triac and back to the power of 120 volts AC. So you could call this like hot and neutral. So from hot through the light bulb, through the triac to neutral, alternating current back and forth like that. And that light bulb illuminated. Now when we stop moving in front of our sensor dome, we had a logic low out here. And the current no longer flowed through the coil of the relay, turning that relay off, opening up that contact, and the light bulb no longer turned on because the triac was turned off inside that solid state relay. Let's put a few of these data sheets up and we'll discuss them. Let's start with the ULN 2003. That is a very, very nice IC. In fact, I left a couple of pin numbers off. I'll write them in here in a minute. Let me go get the data sheet for that IC. Pin 9 is common to all of the freewheeling diodes within those driver array transistors inside that IC. Pin E, that's our ground of the emitters on the transistor driver array. All of the emitters of these inverters, of these transistors, are tied to E. Now I use pin 1 as the input to the first transistor driver array, and pin 16 is the output. Let me move this out of the way and we'll take a look at the diagram of that ULN 2003. In our circuit, we used this one section of that IC, input being on pin 1 and output being on pin 16. And you'll notice that we have all of these freewheeling diodes, these spike suppression diodes on the anode going to the collector of that transistor driver array, and going up to, we tie it up to plus 5 volts. That spike suppression diode prevents damage to that transistor when we are turning on and off coils like solenoids or relays or whatnot. Each of the transistor driver array has its own freewheeling diode, all common cathode up to pin 9. Now you can turn on 24 volt relays, 5 volt relays, 12 volt relays with this driver array by applying 5 volts to the input. It is amazing. It's a nice IC. Here's the block diagram of the solid state relay HD4850-10 manufactured by Credo. Now look how complicated this is inside that block. We have plus 3 is where we applied a positive 5 volts DC and its ground on 4. And that illuminated the internal LED of the optocoupler input. And when photons were emitted from that LED, it turned on this optocoupler triac output. The output turned on these two SCRs who are back to back to make a triac. And the light bulb was connected up here to pin 1 and pin 2, so we had L1 or hot going through the light bulb to pin 1, and then L2 going back to neutral, so that we had current flow through that light bulb. Haha, amazing. These people are pretty smart to put these things together. Now that's a beefy triac output right there. The part number that we had is capable of turning on a load connected to 480 volts AC at 50 amps. So we could turn on almost anything on this earth. 480 volts AC at 50 amps. If we had a load that required that voltage and current, we would be able to do it. Although we'd probably be putting a great strain on this output, but it would do it. Toward the end of the video, I had removed the solid state relay, the light bulb, and the line voltage from this relay connection. And I replaced those items with a 220 ohm resistor and a green LED. Let's see if I can draw that up here. We have the plus 5 volts. That comes over here to a relay contact, and then a 220 ohm resistor and a green LED going to ground. Now I'm getting a little sloppy in my drawing here, but y'all would know what I'm trying to draw. So here is the relay. We'll call it K1. This one right here. And when we had movement from the PIR sensor, this relay would energize and connect our resistor LED circuit to 5 volts and ground. And current would flow from the 5 volt DC power supply through the closed switch, through, let me draw that in there, 220 ohms, through the 220 ohm current limiting resistor, through the anode cathode junction of that green LED to ground, illuminating that LED. You can use this circuit to turn on many different items that you like to control. Alright, there you go. That was a fun circuit to breadboard and experiment with. I hope you enjoyed that video. I'm going to go in the backyard now. It's still chilly around here, like winter don't want to go away. So I got to go into the backyard and fill up the bird feeders. So those critters out there, they don't suffer from the cold as much as we would. Now I went to the shop this morning. Today's Sunday. I went to the shop this morning. I didn't see Tom the shop cat out there, but I put some crunchy cat food out there for him if he shows up later on tonight. I hope so. He's a good cat. He helps me fix things. And when he's not helping me fixing things, he gets in the way. Alright, all. Take care of the critters out there. Take care of your family. Your family is very important. They're the generation that'll come after you. Here we go. Sun goes down. Sun comes up. We get to go do it again.